That's what a power series looks like. Power series, duh. Powers of x, right? It's a very convenient series, and it is very important in mathematics because it leads to a Taylor series and a Maclaurin series. I guess in every calculus class you see a little bit about Taylor series and Maclaurin series in some shape or form, but we're going to see a little bit more of it here. The significance of a power series is it's simple. Further, you can determine where, that is, for what values of x that it converges. Sections 10.1 through 10.6 had the nth term had n's in it, wouldn't you say? But it didn't have x's in it, huh? And what we're going to do is we're going to take something, just to cut through it, that we can't integrate and make a power series out of it, and then integrate that power series. Wouldn't you agree that if x is the variable and c's are constant, that right next to e to the x, that's about the easiest thing in the world to integrate? Add one of the exponent, divide by the new exponent, and do it term-wise, right? So this is the solution. This is the solution to our problem after we've used all of our tricks in chapter 8, and none of them work. And remember, I told you there are those. Then what do? The answer is we find a power series that approximates it. And then we integrate the power series, and if we do a good enough approximation, then we'll be in business, huh? Okay? So, let's for a minute do this. If I do that, don't I have this series? Is that right? All of the C sub n was an arbitrary constant, right? Not so arbitrary as a matter of fact, but a constant. But in any event, I'm going to insist that all of those be 1. Talk about a pretty polynomial, there's one, right? Does that series converge or diverge? Suppose some function f of x is approximated by that series. Suppose some function is approximated by that series. Does it converge or does it diverge? If it diverges, then that series most definitely is not represented by it, right? Would it make sense? I mean, that function, would it make sense to say that a function is equal to a series that diverges, because a series that diverges is really meaningless, isn't it? Would you agree? It doesn't help us one way or the other. So my question is, does that converge or diverge? And believe it or not, even though this is a little bit new, you know the answer to that.
Is it determined by the function?
Yeah, it would. It would. Except I'm going to say in this case, normally what happens, William, is you start with the function and then you make the series, right? But I'm just saying, I made up this series and I want to know, is there a function that's represented by it? Well, you know the answer is yes, because I wouldn't have made it up, right? But let me give you a little clue. Have you ever seen me do this before? You start with 1, and what do you multiply 1 by to get the second term?
X.
And what do you multiply the second term by to get the third term?
X.
And what do you multiply the third term by to get the fourth term? Do you see a pattern here? Is there a name for that series?
Yes.
It is indeed. Everybody agree with that? If that's so, is that right? Isn't that the sum of a geometric series? Agreed? So indeed, that series converges to 1 over 1 minus x. For all values of x or some values of x?
Some values of x.
Some values of x. Which values of x?
Less than 1.
What?
Less than 1. X less than 1.
Exactly. Do you remember the test? If you don't remember the test, you might ought to work on remembering that test between now and the test. But in this test, a geometric series converges for r, in our case, equal to x less than 1. Right? Is that true? So what we're saying is that f of x equal to the series equal to 1 over x, 1 minus 1 over x, converges and all So do you get the idea? The way out of our jam about not being able to integrate things is to make a series out of it. But the problem with the series is it doesn't work for every value of x. So you've got to know what the values of x are. Now, what if, and it's often the case, what if you need to know the integral of all of that at exactly the point that causes you trouble? That is 1. What would you do? Well, instead of starting an approximation at x equals 0, I'd start it at x equal 2. And then what I would find is that the series converges for all values of x less than 2, right? However, 1 is less than 2, so we're in business. You get the idea? And we'll get to all of that, but I want to show you where we're headed. Williams, you're taking circuits. Anybody else had Dr. Freelow yet? Ask Dr. Freelow, Forrest William, if it's a true statement. I'm sure I remember him saying it. He said, quote, "Oh, Miles, you know, most of the time when I'm doing research, I don't mess with all that integration, those techniques of integration. I just do a Taylor series." Have you heard him say it?
Mm-hmm.
That's how nice this is what I'm telling you. Freelow's one of the brightest men I've ever met in my life, and it's not that he can't do it, it's that he thinks this is easier to do it. And as long as the project he's working on will allow him a little bit of wiggle room on the error, and most things you've seen so far in engineering leave you a little bit of tolerance of error. It all depends on the project, how much error you can stand, right? Okay. So do you get the idea? We've added an extra dimension. Everything on that test you're about to take, every A sub n has just n's in it. From here on, our A sub n's are going to have x's and n's in it. And that means that you can't say it either converges or it diverges. You can certainly say it diverges and just quit talking about it. But if you say it converges, you got to know which values of x will allow it to converge. So let's do another one.
Miles, can you explain your explanation of A0 over 1 minus r?
Isn't that the geometric series test?
Okay.
Look at your card and see if that doesn't say what a geometric, and you know me, it's possible I wrote it down wrong, but doesn't a geometric series say that once you call it a geometric series, that the sum of that series is equal to the first term over 1 minus the common ratio?
Okay.
That's where I got it. Questions, anybody? Okay. Oh, I want to show you something sort of cool and make sure you understand what we're doing here. I just love this slide just because it intrigues me, I guess. I did some work in my graduate studies in approximation theory, and this one just sort of is just sort of cool. Oh no, don't tell me I don't have it. I don't. I'll show you on the next one then. I'm going to make a note of myself to put that in there though. many books do it? Not many, okay.
I've got a book.
Have you got one? Do you have one with you? You have one? That's okay, don't dig them out. I'm gonna be able to show you on the next one anyhow. This is example 2 on page 594. I can show you what I was gonna show you on this one. What about that? What about that? Well, whenever you see this, everything, couldn't I just put brackets around all of this and called it in? Do you agree? So whenever you see that the nth term, the whole thing is just written to a power, that ought to scream ratio test to you. Because isn't it saying every time you move along, you're just adding one more multiple of that? Okay? So in this one, I think that the common ratio here is 1/2 times x minus 2. And I think that the, yeah, negative.
That just means it starts at like -1 or something? That's what I was thinking, like, instead of starting at 1.
I got it. Am I not every time multiplying by -1/2 times x minus 2? Isn't that what makes it alternate?
Okay.
Everybody agree? So now I think A0 is equal to 1. That's just the first term, is it not? And the common ratio is R is equal to -1/2 times x minus 2. Huh? So now I'm ready to say that by the ratio test, this converges to 1 over 1 minus -1/2 times x minus 2. You think that's right? Everybody? I think it is. Isn't that 1 minus R? So I think, but that is 1 over 1 plus 1/2 times x minus 2. Everybody agree? But for it to converge, I have to have the absolute value of R has to be less than 1. I remind you again of the ratio test, right? Isn't that it? So does that mean that all of that, that then, suppose I multiply everything by 2 here, and I get 2 over 2 plus x minus 2. Yes or no? I multiplied everything by 2. Is that okay? So that means that the absolute value of 2 over x has to be less than 1. Is that right? Is that right?
So how come you're taking the absolute value of the ratio test and not R itself?
I'm taking the absolute value of R. This is, the ratio test calls for the absolute value of R to be less than 1 in order for it to converge. Then over here I found R, didn't I?
I thought your R was right there.
I think your R is right. I went too far, didn't I? This is so by the ratio test, it converges to 2 over x for absolute value of R less than 1. How about that, Travis? Is that correct? This is the sum of the geometric series, is it not? And this is the ratio of the geometric series. Two different things. And when I picked up something to copy, I picked up the wrong place. So, now I want the absolute value of minus 1/2 times x minus 2 to be less than 1. Everybody agree? But I right off, I'm going to tell you that that's 1/2 times the absolute value of x minus 2 is less than 1. Do you agree with that? Everybody agree? But then that is the absolute value of x minus 2 is less than 2. You agree with that? But then that means that x minus 2 has to be between 2 and minus 2. But that means that x has to be between 0 and 4. inclusive. Okay?
So X is not in all this. It's X.
Say it again now.
X is not in, so it's not actually ever gaining any numbers.
We don't know a value for X yet. We're dealing with some function. What we're dealing with is some function f of X that we can't do anything with, that we make a power series out of. And I want to know, for what values can I use that power series? Follow? Okay? So right now, I know that the IOC is X between 0 and 4. Okay? Now, I need to, so now I need to know, what about the endpoints? The geometric series tells us about a less than 1, doesn't it? What about the endpoints? Well, now we are in business, because what we're going to do is we're going to go to original series, and substitute X equal 0. So doesn't our series become A sub n equal to minus 1/2 to the n minus 2 to the n? Do you guys see what I did? I wanted to find out. I found out that the interval of convergence was 0 to 4, right? But I need to know about the endpoints. I need to know, do I put that little equal sign, that little dash, under the greater than and less than? And I'm not going to make this hard. The book makes it look harder than it is. So what I'm going to do, it gave us the nth term of the series, didn't it? So now, am I back to what's going to be on this test? Now, if I let X be 0, am I back to the test again? Does everybody agree? Everybody agree? Now my question to you is, at X equal 1, does that series converge?
It does.
Does the sum converge? If a sum of just keep adding 1s, does it converge? What's the common ratio? What I'm telling you is, then the sum from n equals 0 to infinity is equal to 1 plus 1 plus 1 plus 1 plus 1 plus one. What's the common ratio?
One.
So, does it converge, Byers?
No.
No. Everybody agree? So, now I can say that is okay like that, meaning I would have had to go back and put an equal sign under it if it had converged, right? Everybody? So now I'm just going to do the same thing again. I'm going to, now I'm going to go to original series.
Substitute x equals
I'm going to go to the original series and let x equal 4. So in that original series, my nth term is minus a sub n is equal to minus 1/2 times 4 minus 2 to the nth power. Did I do that right? Which is equal to minus 1/2 minus 1/2 to the nth times 2 to the nth, which is equal to minus 1 to the nth. Does that series converge? What's R going to be in that series?
-1.
A -1? Does everybody agree? So this is a geometric series with R equal -1. So the absolute value of R is equal to, so it does not converge at x equal 4. For the same reason, right? Everybody agree? So now I know that the given series, the one that, whoops, let me save this while I'm thinking about it. Four, 14. Now I know that the given series converges, right? And I know where it converges. So I know that this one is okay also, is it not? So, here's my conclusion. Any questions about what we've done while I've got it on that view? Any questions? Let's go through and review it. What I did is I looked at the series. I noticed that the series was a geometric series. So I found where it converges in terms of x, right? And then I decided I had to find out which particular values of x would work. Okay? And I did. Then I found everything but at the end point, right? And I checked the endpoints, and neither of them work either. Everybody follow? Okay? So here's what Dr. Freelow would say if he were using it. So he would tell his research partner, I've got our problem taken care of, but if you get outside of x equals 0 and x equals 4, tell me again, and I'll have to move it over for you. Follow what I'm saying, everybody? That's cool. That's cool because what that does is that's our way out of some really, really ugly intervals. And my DE class is about to learn that's my way out of some differential equations that I can't solve. Okay. How about this one? This is example 3 on page 594. Oh, here's what I was going to show you a minute ago. I think this is a cool picture, but not in differential equations. Ready to see that one just yet. here's what this shows you. This shows you the obvious, but it makes it even more obvious. I'm not sure. Think about what I just said. How much more obvious can obvious be? But anyhow, we'll say that for another day. Remember, think of this in terms of how big n is, right? And that series. After one term, all I've got to approximate it is a straight line. After two terms, that series becomes this. And it is a little bit better line to approximate it. Do you agree? After three terms, it becomes a parabola, doesn't it? And it becomes a little bit better approximation. This one is the real sum of the first series we did. So what I'm telling you is, do you notice that as n goes up, look how much better the approximations get? But also look, that first series was around x equals 0. Do you remember that? Remember that? And it is perfect right there. But the further you get away from that point, notice how it drifts apart. And what I'm telling you in every case is that this distance right here, from this distance is the that's how much they're off. So do you get the idea? So obviously it only works in a close area around the point where you start. Okay? So do everybody understand what we're doing? And if you want, instead of studying it around this area, if you want to study it around this area, you just move your series over, huh? And I'm going to show you how to do that. Okay? Everybody all right with that? Did you see how much my screen is off? I got to fix that. But this one time...
Are they always going to give us the nth term with these power series?
Yeah, that's what a power series is about.
But like on the one you showed us, they just gave us like 2, and then they said ... and they were like, well, this is what it actually is.
Yes, yes. Yes, what that means is you go as high as you need to go to get it right.
I think what you just did earlier is what we used to do in Calculus 1.
Exactly.
Yeah.
Exactly. And that's what I'm saying. We talk about Taylor series. A power series is nothing but a modified Taylor series. And, now why didn't that work? Maybe it is trying to work. A power series is nothing but a modified Taylor series. land. How'd this get to be so hard? Usually the answer to that question is I made it hard. I turned off the violin music. Okay? Let's look at, this is example 3 on page 594. That made it worse, not better. PS is power series, huh? Okay? So I've got a power series. That's a power series. And notice I left the limits off because I was too lazy to write them, and the book indeed said that the limits were 1 to infinity, and isn't that our rule? We can be lazy when we have 1 to infinity. And that's A sub n. I want to know if a series converges. No, if a series diverges, what's the interval of convergence?
Is it in anything or in this one?
If any series diverges, what's the integral of convergence?
If it diverges.
If it diverges, what's the interval of convergence? The interval of convergence is the values of x that make that series converge. So if it diverges, what's the interval of convergence?
0. Nothing. It does not exist.
Not 0 is something. So you can't say 0 and nothing, right? I know. Don't we say stupid things in math? But do you follow what I'm saying? 0 is a number, huh? So if you say 0, you're implying that a number works. By the way, that is the right answer. It's the single point 0. Why? Well, if it diverges, there is no x between this and that. Would you agree? And if, for example, that series diverges, which, by the way, it doesn't, it does not, but if it did, wouldn't we have a single point 0? If x were equal to 0, what would every term of that series be?
0.
And what would the sum be?
0.
And therefore it converges to what?
0.
Follow? Okay?
The last one converged from 0 to 4?
Yes.
Okay.
That's what I mean. What Dr. Freelow would say to his research partner is, here's your series that works, but it only works between 0 and 4. That's what he would tell him. Okay. Now, so I want to know. First thing I want to know is I want to know, does it converge? What kind of series is that? What kind of series is that?
Ratio?
What? No, what kind of series is that?
Alternating?
What?
Alternating?
Yes.
Yeah.
It's an alternating series. Okay. What I'm going to do is I'm going to use the ratio test to determine I think, so I have then the ratio test. I want A sub n plus 1 over A sub n. Isn't that the way we do the ratio test? So isn't this equal to x to the n plus 1 over n plus 1 times n over x to the n? Y'all remember I'm dividing, right? But when I write it, I invert the denominator and multiply. Everybody okay with that, I suppose? If you're not, I need to know right now. Everybody okay with that? All right. I think everybody agree with that? I can't do anything with those n's, can I? If they were factorials, I sure could, couldn't I? But they're not. Agreed? Everybody? Okay?
Well, how the absolute value of x come about?
Because, well, William, because it was an absolute value to begin with.
Okay, that's right.
See, look, I wrote this in absolute value, but when I substituted in, I left the absolute value off. And the absolute value, does the absolute value matter for n's? Because n doesn't end by leaving that off. Doesn't n start at 1 and go up? So they're all positive anyhow. Okay?
And it was the xn's canceled, so you just had x to the 1.
When I took the absolute value, didn't the negative 1 go away too? Is that right? Everybody agree? So are we okay with all that? Okay. Now, what does the ratio test say?
Add 1 to the nth power.
No, I'm sorry, that wasn't a good question. Now, what do I do? In order to make a decision about that, the ratio test says that the series converges when above the arrow is what?
Less than 1.
Is less than 1 as n goes to infinity. Is that right? Isn't that what the ratio test says? So now I take the limit as n, not x, approaches infinity of n over n plus 1 times the absolute value of x. But I think that is equal to the absolute value of x by the man. I guess we talk about him more than anybody, don't we? In its present form, isn't it infinity over infinity? That allows us to invoke L'Hopital's rule. And now instead of taking derivatives, what am I taking? Partial derivatives. Because I have two variables, right? And you remember the way, you don't know, damn, this is Cal 3, I'm sorry. I can't tell you about partial derivatives. It's a deep, dark secret.
It's just like partial integration.
Yeah, well, what would you say to that?
Integration by parts.
Mm-hmm. Now, it's all I can say is that I'm only considering the limit of n, so I only apply L'Hopital's rule with n. How about that?
Is that in Cal 4, the
Yeah,
third dimension?
Cal 4 is. That's the third dimension, and I forgot I can't talk to you about it. Let's just say this. If we're taking the limit with respect to n, when you use L'Hopital's rule, it's only with respect to n. How about that? Let's just say that. Okay? But then we know that the series converges when the absolute value of x is less than 1. Isn't that the ratio test? Don't you go through, you calculate this, then you take the limit of it, and then before we got some number, didn't we? On the test you're going to take starting tomorrow, right where I'm pointing will be a number. And if that number is less than 1, you're in business. If the number is greater than 1, you don't know. No, if it's greater than 1, it doesn't converge, and if it's equal to 1, you don't know. Everybody agree? Okay. So, now I know that means that x has to be between 1 and minus 1. I still don't know about the endpoints, do I? Do you agree? Do you remember here's what I'm trying to tell you. The ratio test says that it is inconclusive at the endpoints. Doesn't that mean it might converge there and it might not converge there? And we'd have to find out. So all I'm going to do now is test the endpoints. So what I'm going to do is now test x equal minus 1. If x is equal to minus 1, then a sub n is equal to minus 1 to the n minus 1 times minus 1 to the n over n. You follow? I just substituted x equal minus 1 in the original series. Everybody agree? So now I have I said, I think this is equal to, minus 1 to the n times minus 1 to the minus 1 times minus 1 to the n over n. Virus, what do you think? Isn't that the way you do it? So, watch this. We'll just play around a little bit with some algebra. That then is equal to minus 1 times minus 1 to the 2n over n. Everybody agree with that? But I think that's equal to minus 1 times minus 1 squared over n. Yes or no? What I'm saying is, if I raise something to a power where I'm multiplying exponents, isn't minus 1 to the 2n the same as minus 1 to the 2 to the nth power? And minus 1 squared is indeed plus 1, huh? And plus 1 to the nth, I don't care what n is 1. So I'm through with that. Everybody agree? Everybody agree?
From the second step to the third step.
Second step to the third step.
where you have your initial problem, and then set equals.
Okay, from the second step to the third step,
No, up one.
from there to there,
Yeah,
okay?
you have,
Don't you add these exponents? For all I did was break that up, right? Right? I broke from the first step to the second, you're okay. But you add the exponents here, so what's n plus n?
oh, okay, never mind.
Okay?
I figured it out.
And minus 1 to the minus 1 power is 1 over minus 1, right? Which is minus 1. Thank you, Travis. I should have said that. This is that, isn't it? Okay? Now, I want to know, then, now I need to know, does that converge or not? And the answer is?
Converges. It's alternating series.
Alternating series. It converges conditionally. It converges conditionally, but it doesn't converge absolutely, huh? Is that right? So what I'm saying is,
I think
what I'm saying is, this series diverges because if I'm testing to see if it converges absolutely, the minute I take the absolute value of that nth term, don't I get this? And isn't that the series that I said you don't even have to explain to me why it diverges? Is that right? So we know that minus 1 is not in the interval of convergence. Everybody agree? Everybody agree? So now I test x equal 1. So I have minus 1 to the n times, I gotta look, times 1 to the n over n times 1 to the n over n. Is that right? Okay.
could you just put it in the one you did earlier, or did that not work?
Well, that is a sub n, huh? Right? Now, I want to consider, does it converge? So, using the ratio test, the absolute value of a sub n plus 1 over a sub n is equal to minus 1 to the n plus 1 times 1 to the n plus 1 over n plus 1 times n over minus 1 to the n times 1 to the n. But all of this in absolute value is 1.
Do we need that minus 1 after the first term on the a sub n equation, where it says negative 1 to the n?
Let's see.
Would it be negative 1 to the n minus 1?
Let me get this right. This is minus 1 to the n, right? And then times 1 to the n. I'm getting it. Agreed? Did that answer your question? I'm trying to add n plus 1 here, so I did minus 1 to the n plus 1, then I did 1 to the n plus 1, and then I did n plus 1 there.
What I was saying is the original equation says negative 1 to the n minus 1.
Get it?
Mm-hmm.
Doesn't it?
Yes. Does it matter? Not in absolute value, it doesn't.
Okay.
But thank you. If I do n minus 1 and add 1 to it, don't I get minus 1 to the n? Is that right? And then this one would be n minus 1, wouldn't it? Is that right? Does that put it back as, I put that n minus 1 there, does that fix it?
Yes, sir.
Okay, thank you. Thank you. All I'm telling you is, in absolute value, that minus 1 becomes a plus 1, right? And I got 1 times 1 a whole bunch of times. Do you agree? And down here, I got 1 times 1 a whole bunch of times. So don't I get n over n plus 1? Everybody?